Algebra 1, Chapter 9, Section 1. Quick note before we do the lesson is that Chapter 9, just a fair warning, is very skill-based. It's a skill-building chapter. Number one skill to learn is what's known as factoring, which will come in future sections. The latter half of the chapter especially is devoted to factoring. This is a huge skill that you need to have. It's not optional. It is paramount that you're a good factorer. And so please take that to note that and take that to heart. Make sure that you're really good at this by the end of this chapter. And we'll have plenty of practice along the way. Before we get to factoring, we have to learn multiplication. And before we get to those two topics, we have to deal with what might be considered simpler topics, which would be adding and subtracting. So that's what Section 9.1 is about, adding and subtracting polynomials. We have some definitions here. Monomial, polynomial, binomial, trinomial. They're not in exactly the right order necessarily. This is the way that your book does introduce them. But really what is happening here is that there's something called a polynomial. The prefix poly means many, and it is the umbrella term for all of the rest. Okay, so a monomial is a polynomial. A binomial is a polynomial, so is a trinomial. They're all polynomials. If there are more than three terms, because mono means one, bi means two, and tri means three. If there's more than three, then those will also fall under the umbrella of polynomial. Again, the prefix poly means many. So if it's more than that, we don't have words for those. If it's 4 terms, we'll just say 4-term polynomial. If it's 19 terms, you better hope I don't give you a problem like that. But if it's 19 terms, we would just say a 19-term polynomial. So the definition there of monomial, you can see, and then it speaks of the degree of a monomial. You can see where I'm speaking of. That's right here. The degree of a monomial is the sum of the exponents of the variables in the expression. Okay, so a few examples. 3x squared is a degree of 2. The exponent would be the degree. So 3x squared, this 2 would denote the degree. It's 2. 16t is like saying 16t to the first power. So that is a degree of 1. X to the first power, degree of 1. Y to the 8th is a degree of 8. Now, to fully understand that definition of the degree of a monomial, if you had something like a to the third, b to the second, that's a degree of 5. A to the third, b to the second, 3 plus 2 would be 5. That's a degree of 5. Now listen carefully about that topic, because that can be a point of confusion. The sum in one term, the sum of the sum of the exponents is the degree. That's not to be confused with what you see next when it deals with degree. The degree of a polynomial is the highest degree of any of its terms after the polynomial has been simplified. Okay, so I've used the word term a couple of times. Let me make sure that you understand. A term in a polynomial is separated from other terms by a plus sign or a minus sign. Not multiplication, not division, not exponents, but a plus or a minus sign. Okay, so there can be multiple terms in a polynomial. A monomial has just one term. If you look down here at binomial, x plus 3, that's 2 terms. X is a term, 3 is a term. And what I'm telling you about the degree, both of monomial and the degree of a polynomial, if I look at x plus 3, well, the degree of x would be 1. The degree of 3 would be 0. So the degree of this polynomial is 1. It's the highest degree of any of its terms. X is a term, 3 is a term. By the way, x is also a monomial. 3 is a monomial. So the word term and the word monomial can really be used interchangeably. This binomial has a degree of 1. This binomial here has a degree of 2. X squared is a degree of 2. Y squared is a degree of 2. Really, I could look at either one because they both have a degree of 2. The degree of that polynomial is 2. Trinomial. There's a pretty common one. 5x squared plus 2x minus 3. We'll call that a quadratic. Has a degree of 2. You see how it's not cumulative? It's not that you're considering this one as well. Again, to not confuse that with what I said at the beginning about the degree of a monomial, that example was not separated by a plus sign or a minus sign. I think I said a to the third, b to the second. Not plus or minus, just times. A to the third, b to the second would be multiplication. So here you have 5x squared, that's degree 2. 2x, that's degree 1. 3 is degree 0, so the degree is the highest one, 2. A squared plus 2ab plus b squared would also be a degree of 2. In fact, each one of these terms has a degree of 2. Here's a degree of 2. 2a to the first, b to the first, that's add them up, that's a degree of 2. B squared, degree 2. It is customary to write the terms in descending order of the exponents of its terms, largest exponent first. Okay, so that's what you see in a few examples above. 4x to the third plus x squared plus 6x plus 8 is a convenient way to write it. We have a name for this. It's called standard form. Okay, the descending order. The highest exponent should be first, then the next lowest, then the next highest, then the next highest, then the next highest, down to the lowest. And then finally, and this doesn't get as much. This doesn't get as much space as it should on my notes here, but it says polynomials can also be classified by their degree: linear, quadratic, cubic. If it's of degree 1, we already know that word. That's linear. Refer back to chapter 6. Everything that we dealt with there was lines. Quadratic means it has a squared in it. X squared, a squared, whatever, as its degree being 2. That's quadratic. If it's degree 3, that's cubic. If it gets higher than that, we just say fourth degree. Now that should say degree right there. I typed it in, but for some reason it's not showing that on the screen. But that should say, if you're one who's taking notes, linear, quadratic, cubic, fourth degree, etc. Fifth degree, sixth degree, seventh degree. We don't have words above cubic. We just say fourth degree, fifth degree, sixth degree. All right, let's do a few examples. Find the degree of the monomial. Find the degree of the monomial. 18. Now, 18 is degree 0. Okay, this is like saying 18x to the 0. You would have learned in a previous chapter, chapter 8, that anything to the 0 power is 1. So 18 is like saying 18x to the 0. That's like 18 times 1, which is just 18. In fact, really, it's kind of like saying 18x to the 0, y to the 0, z to the 0, or whatever. All of those things are 1, so we don't bother to write those. It's just 18, degree 0. 3xy to the third, break that down. That's 3x to the first, y to the third. That's one term. 1 plus 3 is 4. X to the first, y to the third. 1 plus 3 is 4. This would be a degree 4. 6c is like saying 6c to the first. This one would be degree 1. Okay, next example. Write each polynomial in standard form. Like we said in the notes, standard form meaning descending order. Then name each polynomial by its degree and the number of its terms. -2 plus 7x is not in standard form, so we should switch those two terms around. 7x minus 2 would be in standard form. 7x minus 2, standard form, descending order. And then this would be, as we just went over, this would be a linear binomial. Linear based on its degree, binomial based on the number of terms. Linear binomial. This next one has two like terms, 3x to the fifth minus 2x to the fifth. Those are like terms, things that you can combine. You should do that before you attempt to classify it by its degree or its number of terms. So 3x to the fifth minus 2x to the fifth would just be x to the fifth. The next term should be the 7x. The next term should be the -2. Like that. This is standard form. And that is a fifth degree trinomial. 3 terms, trinomial, fifth degree because of the 5 here. Fifth degree trinomial. By the way, there's a nice summary in your book. I didn't include it here for time's sake, but there's a nice summary in your book of not only the degree, but also classifying by the number of terms. It's on page 495 in your book, the green box there, if you need more of a summary there. Okay, last two examples would be addition and subtraction. Let me scroll ahead here and show you what they're going to do. They have two different methods. The first method they're going to show is to add vertically. I do not like this method. I'm not going to model this method for you for any of the operations in Chapter 9 or beyond. I do not think you're setting yourself up for success if you're going to add vertically or subtract or whatever. I'm going to do it horizontally, what they would call method 2. You say, why are you bringing this up? Just show us the right way. Well, because if you looked in your book, they're going to show you both methods. And I think that you're going to do yourself better success-wise in the future if you would add horizontally, okay, like they're going to show here. Actually, let's do this one. When you're adding things, the parentheses are not necessary, so I can go ahead and just rewrite this, but I can leave the parentheses out. 6x squared plus 3x plus 7 plus 2x squared minus 6x minus 4. Because it's addition, I can just remove parentheses. Nothing changes when I add a quantity in parentheses. Now, I notice like terms. 6x squared plus 2x squared would be 8x squared. 3x minus 6x would be negative 3x. And 7 minus 4 would be 3. This is 8x squared minus 3x plus 3 once you simplify by adding. And that's what they're showing there in their bottom method. Notice we got the same thing. 8x squared minus 3x plus 3, 8x squared minus 3x plus 3. Again, the adding horizontally method is better. I would steer away from this. That's more than a personal opinion. My colleagues would all agree with me on that. Last example would be subtraction. Okay, now unlike the last example, the parentheses do matter here. So as I remove parentheses, I want to keep in mind that I'm subtracting this entire quantity. So yes, I'm going to remove parentheses. And actually, before I get to that, just real quick, again, they have a vertical method for this. I'm not a fan. I would rather you subtract horizontally this way. And this is the method I'm just about to show you here. Two x to the third plus 4x squared minus 6. And then this minus means that as you're subtracting each one of these terms, you're subtracting 5x to the third, you're subtracting 2x, you're subtracting negative 2. Now you should have heard something there. It's minus negative 2. It's going to change every sign in those parentheses. So 5x to the third becomes negative 5x to the third, minus 2x, and minus negative 2 would be plus 2. Okay? Some teachers will say that it's like distributing the negative, and I like that. That's a good way to think of it. You're distributing the negative, so it changes all those terms. And now I'm looking for like terms. 2x to the third minus 5x to the third. Those are alike. That would be negative 3x to the third. 4x squared doesn't have anything that's alike with it, so it gets its own spot there, 4x squared. I'm not sure I said that right. If I said to the third, I mean squared, plus 4x squared. The next thing, so this one's taken care of. The next thing would be negative 2x. Also, nothing alike with it. Finally, though, negative 6 plus 2 is the constant. This is descending order. This is degree 3, degree 2, degree 1, degree 0. The whole polynomial has a degree of just this one, which is degree 3. But this is how we want to write this in descending order. Double check my answer here. That is correct. Okay, good luck with your homework.